Okay, example number 2 deals with translations on the coordinate plane, so kind of on a graph. In this example, we have a scavenger hunt, where Travis is on a scavenger hunt at the lake. He needs to swim to the nearest buoy, so I think he's starting here where this little dot is. This is Travis. They don't have him labeled, but starts here at the origin. He has to swim to this buoy, pick up a card, and then swim until he reaches a fisherman, who will give him the next clue in exchange for the card. Describe the translation from the buoy to the fisherman's boat by using a translation vector. So specifically, we just want to say, what does Travis need to do to get from the buoy to the fisherman's boat? What direction does he need to travel, and how far does he need to travel? Now remember that magnitude and direction are kind of just tied up in those two numbers that we use to describe the vector. So they're just tied up in how far do we go in the x direction and how far do we go in the y direction. Okay, so describe the task in your own words. Basically what I just said. We want to figure out how far away and in what direction he needs to travel. Okay, so approaching the task, we're going to use, let's look at the questions, I guess. Describe the location of the buoy on the coordinate plane. Okay, so they want the description of where the buoy's at, the location of the fisherman's boat, the direction of Travis's route, and what is the translation vector. Okay, so we have a buoy that's at 3-2 and a fisherman at 8-1. So let's put those in, and with that information, we should be good. So 3-2 and 8-1. Okay. Therefore, our vector is the movement that gets us from our x location, 3, to our new x location, 8. Okay, so that'd be plus 5. And our movement in our y direction. So we start at 2, we go down to 1. Okay, so it looks like we have -1 as our change in the y direction. We're going down. Okay, so this is our translation vector. The direction of Travis's route is, I don't know, I guess you'd say down and to the left, or sorry, down and to the right, more to the right than down. I don't really know what kind of wording we're looking for here, but that's the general direction. It's down and to the right. And that's it. So this is how you would describe that vector between these 2 points. If it asks for the distance, once again, we could kind of say, I'm going to make a right triangle. I'm going to use Pythagorean theorem to do a squared plus b squared equals c squared. However, that question's not coming up right now, so we'll leave it for another time.